Okay, so in this video I'm gonna show you how to make this menu project using the OLED display and this Arduino compatible chip being the ATtiny85. And that's this small chip right on the breadboard. This project is sponsored by PCBWay, but more about them later in the video. As I press those two buttons, I can scroll through the menu and it's actually pretty fast. Now this project is based on my older project where I was using the very same menu but using the Arduino Uno. You should definitely watch the video if you haven't done it already because it has all the important details. I will put the link down in the description of this video. And there are actually two videos. One is showing how to make this project using the U8G1 library, the older version of the library. And there is also a second video using the U8G2 library, the newer version of the library. Unfortunately, none of those libraries could be used with the ATtiny85 chip simply because there is not enough memory. The Arduino Uno has 32 kilobytes of flash memory and 2 kilobytes of RAM memory. The ATtiny85 has the memory 4 times smaller, meaning that it has only 8 kilobytes of flash memory and half kilobyte of RAM memory. And that's not very much because our used display has the resolution of 128 by 64 pixels, so it's 8192 pixels that we need to update. And if we want to store this inside the RAM memory, we would need 8192 bits or 1024 bytes. Again, the RAM memory on the ATtiny85 is only half kilobyte, meaning 512 bytes, so there is no way how we can squeeze this frame buffer into the RAM memory. Thankfully, the display itself has a memory big enough to hold the content of the display, but there is one limitation. We cannot read the memory, we can only write to the memory. And the smallest amount of data that we can write is 1 byte, which consists of 8 bits, and those 8 bits are 8 pixels. So at any time, we cannot just update 1 pixel, but we need to update at least 8 pixels. This is our screen sized 128 by 64 pixels. And we can imagine that the screen is being split into 8 different pages. So 1, 2, 3, 4, 5, 6, 7, 8. And each page is sized 128 by 8 pixels. Now for drawing on the X position we can set any value, but for Y position we need to jump by pages and we always need to fill the entire height of the page. So for example, if I want to fill the pixel in here, I also need to fill other pixels around to fill the entire height of the page. If you want to know more about this, I have a video describing recreation of my old turbo gauge project using again the ATtiny85. As usual, I will put the link down in the description. But back to our project. Actually, before we do that, let's talk about the sponsor of today's video, which is PCBWay. And not only can you get PCBs, PCB assembly and SMD stencils, you can also get CNC machining and 3D printing. And they are always running some extra promotions, so there is always a way how to save money. For example, right now, I think there is this Christmas design challenge where you can get some coupons if you design a Christmas theme PCB. Which reminds me that I've designed a Christmas PCB last year, but I was kind of late for Christmas. Anyway, thank you PCBWay for sponsoring this video. Also, if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. Anyway, let's get back to our project. This is the screenshot from the original project using the Arduino Uno. And it might not be obvious, but all those icons are sized 16 by 16 pixels, although it's not always filling the entire space of the icon. However, what's important is that this top icon as well as the bottom icon are sized 16 by 16 pixels, but they actually span over 3 different pages, meaning they had to be exported as 16 by 24 pixel image instead. And not just that, you can see that as we export this as a 16 by 24 image, so this will be the size of the image, the icon will have to also include the outline of the selected item. Actually just the top one, because the bottom one will have to include the other part. That one would have to include the top outline. So in the end we would need 3 different versions for each icon, the top one being 16 by 24 pixels, the middle one being 16 by 16 pixels, and the bottom one being 16 by 24 pixels. But I think that the better solution is to actually move stuff around, so those icons are always only in 2 pages. And it shouldn't be hard. I think that the only thing that we need to do is to move the top icon 2 pixels to the top, and the bottom icon together with the text 2 pixels to the bottom, like so. So now every single icon could be exported as a 16 by 16 pixel image. There is also a nice side effect to this change. Now every single label has a distance from the baseline to the bottom of the page, exactly 3 pixels. Which means that we can use the same font, but as you can see, text is spanning across 2 pages. So it would be nice to use the library that supports labels to be bigger than just one page. And thankfully that library exists, and it's called Tiny 4K OLED. And it's even mentioned here that this is created for the ATtiny85 to be used with the SSD 1306 OLED display. So it should be a perfect fit. One big advantage of the Tiny 4K OLED library is that it has a lot of examples running on the Walkway emulator, which of course makes things much easier to use. And so one of the examples is called the double size smooth text, so I'll open it and run it in the Walkway. And we actually don't need the double size text because I believe that this one takes like a half of the screen, so 4 pages. We are perfectly fine with this one, which only takes 2 pages. So I'll delete the double size smooth text and only keep the normal size, and actually only keep this font, which is a font 8x16p. And if I restart the simulation, you can see that we have text displayed on the display, which takes 2 pages, and I can copy this image and paste it in a Photopea, and we can see that this text is really taking 2 pages, so I can copy it and show it over our current image. And I'm sure that you can use this font, but I wanted this project to look like the original one, the one using the Arduino Uno, so I've decided to create my own font. And I think that the currently used one, the one being called font 8x16p, might be a good start. So I will jump into the source code, open the src folder, and locate the font 8x16p.h, copy the file, and then jump to Walkway and create a new file. Let's call this custom font.h, create the font and paste the content. And we need to use different names to prevent collisions. So for example, add the underscore text for every single variable. So that's this one, which contains all the data for the font. But there are also some variables down there. So this will be also underscore text, as well as all those ones, just like that. And then we need to include this file into our main sketch. So I will include the file custom font, and we need to put it inside a bracket, so custom font.h. And let's use this font name, so font 8x16p underscore test. If I restart the simulation, I should see the very same looking text, but now I can make changes inside this header file. And I will start by examining the content of this data. So for example, this is the data for the ampersand symbol, so I'll copy it into clipboard and jump to image to CPP website and paste the byte array in here. And I can count the number of bytes, so it's 1, 2, 3, 4, 5, 6, 7, 8 times 2. So let's try 8x16 and read as horizontal, and there is some strange looking image, so I will click the read as vertical, and now we should see the ampersand. So we know that we need to generate those images in the vertical format, and let's actually try that with one character. Back in Photopea, I will select the area of one character, for example the character G, so the selection is 5x16 pixels, then copy it into clipboard by going to edit, copy, merged, create a new file in the same size, so 5x16, create it, paste it, and then go to file, export as PNG image. Jump back to the image to CPP website and select our image. Make sure that the draw mode is set to vertical, and then generate the code. And we are only interested in this byte array, so I'll just copy those individual bytes and let's just paste it into our font, maybe instead of the first symbol, which will be a space character. So I'll just paste it in here. So we will reuse the space character for the letter G for now, and we know that the weight of the character is 5 pixels, so we also need to change the arrays down below. So for the first entry it will not be 7 pixels but 5 pixels instead, and I also need to change it down here. So now if I jump into the main sketch, I can include some spaces, and let's just for example say hello world and change the position to 0, 0 and restart the simulation. And we should see a letter G instead of every single space character. Again, I can copy this into clipboard, paste into Photopea into our screenshot, and if I only copy this piece of image, I can position it next to the gauge label and confirm that it looks the same. So now it's just a question of creating an image for every single character in the font. So I've created this image, which includes all the characters from the used font, the font being the pixel operator in the bold and size 16 pixels. And just because those are individual layers, I can export those by going into File, Export Layers, and then Export Layers. And this is how it looks like. I have all those characters as individual images, so I can jump into the image to CPP website, select all the images, and then generate the code, but unfortunately it's not working. I mean, I can see the preview of all the images, but when I click the vertical and generate the code, somehow I'm not getting the expected result. And it's much more visible if I only select few files. So for example, let's select the exclamation mark and then the hash symbol. And if I scroll down, you can see that the size of the exclamation mark is 2x16 pixels and the hash symbol is 7x16 pixels. But when I switch to vertical and generate the code, and I can switch to the plain bytes, you can see that even for the 2x16 image, I'm getting way too many bytes. And I should really be only getting 4 bytes, but it seems like that the content is spread across I don't know, 7 bytes. It's kind of strange and definitely not something that I can use. Now I can select image after image and that should be working just fine, but that will of course take me forever, so I was looking for a different option how to do that. And thankfully Photopea, just like real Photoshop, supports scripting. Back in Photopea I can go to File, Scripts, and there are some predefined scripts starting with this Hello World message. If I run this I will just see the Hello Photopea message. But there is also an example for duplicating layers, which is this one. It will create a 12 copy. If I run this I get 12 copy of the current layer. And there is also a third example called Process Layers, and it just goes over the layers, and if you want you can set the opacity as well as change the layer name. So if I run this, I can change the layer name as well as opacity, or for example the visibility. And I've used bits and pieces from all of those free scripts to create my own script. So here is what I want to achieve. I want to create one single image that will include all the characters that I can later use in the Image2CPP website to generate the byte array. And the byte array will be created in the vertical file format, so it will be first byte and the second byte and the third byte and so on and so on. But the problem is that I want to generate those bytes for the upper half of the character and then jump to the lower half of the character. And after I generate those, I want to of course jump to the next character, to the upper half, and then to the bottom half, and so on and so on. And there is unfortunately no way how I can do this without having extra information of the width of those characters, so I have to do some slight workaround. Instead of the image being 16 pixels tall, I will only make it 8 pixels tall, and then I will have every character twice. So there will be the upper half and the lower half, and then the upper half and the lower half, and so on and so on. And obviously doing this by hand will take me a lot of time, but hopefully with the help of scripting, it should be just a few clicks. And the final script looks something like this. I will not go over all the details, you can get the script on GitHub and take a look by yourself, but I will show you how to use this script. So I'll just copy the script in the clipboard, and inside Photopea I need to have the image already created, and in this case the height of the image should be 16 pixels, and I should have one text label in here with the correct font. In my case that's a pixel operator in the regular size, being 16 pixels, the anti-aliasing set to none, and the color set to white color. I need to set the correct Y position, and I've already told you that the distance between the baseline and the bottom of the page should be 3 pixels. Then I can go to File, Scripts and paste our script in there, and now I can press the Run button. Now there is one very important thing. I need to get the sizes, the widths of those individual characters into our Arduino code, and while you can copy stuff into clipboard in a real Photoshop, you cannot do this in Photopea. So I'm basically reusing this dialog to get the information from Photopea outside to the world. So what I need to do is to copy this, and if I paste it into Notepad, I get all the widths, and then I can close the dialog in Photopea, and you will see our new image with all those characters being in there. Again, it looks kind of strange because I have the upper half and the lower half, so it's kind of hard to see what's going on. But this is all we need to create the byte array in the Image2CPP website. So I'll jump to File, Export as PNG layer, click the Save button, and use the Image2CPP website to generate the byte array in the vertical file format. Click the Generate Code, and we should have all those individual bytes. Now we just need to use all the data inside our code on Walkway. So for the Image2CPP website, I will copy the output and paste it into the custom font inside this main array. So I'll just delete everything that was there previously and paste it, and make sure that I'm only pasting the content of the array, so not the array definition, which should be up here. So I'll delete this one and keep the old name, the font 8x16_test. So this is the content of the file. And then I need to update those sizes, which I have copied previously. So this is the first array, and you can see that those values are separated by comma. I will delete the last one. The second array is called width 16, and in this case, every 16 values are added together and then separated by the comma. So I'll just again copy and paste it and delete the last plus symbol. And hopefully that should be everything that's needed. So I'll restart our simulation. And as you can see, the label is displayed in our new font. Now our menu has two different fonts being used, this normal one and also a bold one. So I will repeat the process one more time with the bold font, again using the custom script in Photopea and the Image2CPP website, and pasting everything into a new header file inside the Walkway emulator. Just to have some meaningful names, I've renamed the first font to be font pixel OP16 and also updated the name of the header file, and the second font is font pixel OP16B for bold, which is also matching the name of the header file. So now we have those two header files and we can test the font. So again, the first one is this name. I will copy it into main sketch, then change the Y position and use the bold font that's this name, and maybe one more line on position Y6, and let's restart the simulation. And suddenly it looks much more like a menu. We are of course missing a few elements, the icons, the selected item background, and the scroll bar. But before we add those, let's make a few small tweaks. First of all, the labels should be displayed on the position X being 25, so the X should be 25 for all of those, and let's maybe use some more meaningful strings. And move all of this inside the main loop, don't add any delay, and delete this custom function called normal size. Actually, I don't think that I need this commented out text, so I'll delete this one as well. That will simplify our sketch even more. And this is how it looks like once I restart the simulation. Now as for the background, I will use the image from Photopea, being a full screen image but not showing any labels, so I'll hide the labels and the icons, and I will export an image like this going to File, Export as PNG image. Now you might be thinking that drawing the full screen image will take a lot of time, and it will, but we will only draw it once inside the setup function, and then we'll just redraw the labels and the icons inside the loop function, so it should be fine. Once the image is exported, I will use the image to CPP website to generate the byte array. Again, make sure that the draw mode is set to vertical, generate code and copy the output. And inside our walk with simulation, I will add a new file and call it bg.h for background header file and paste the image without the helper array. Copy the name of the image, and inside the main file, make sure to include this file, so include bg.h. And we want to draw the image inside the setup function. And again, the tiny 4K OLED has some walkway examples, for example this one called bitmap, which is drawing a bitmap. So I will borrow this function called OLED bitmap and paste it in our code. Use the correct image name, and the position should be 0, 0. The width, actually the right side of the image, is 128 pixels, and the height is in pages, which is 8 pages. Now there is this clear function, which clears the content of the display. Obviously that should be before drawing the bitmap, but because we are drawing a full screen bitmap, we don't have to clear anything, because the bitmap will pretty much cover everything that was in there previously. So let's restart the simulation and see how it looks like. And more, it looks like a menu. So I think it's time to open the Arduino Uno version of the menu and start copying bits and pieces of the code into our ATtiny85 version of the menu. And since in here I include all the images in the main file, I have to scroll all the way down to find the start of the sketch, which seems to be around here. So we have the number of items, which is the maximum number of items, and the maximum length for those individual items. Both of those are used in this menu items array, and I think that we need this in our code as well, so I'll copy this inside our code. Let's not worry about buttons at this point, but we want to know which item is selected and which was previous and which is next, so I'll copy those 3 lines into our code as well. And then I guess somewhere inside the main loop we are calculating those values, so I will search for the item cell previous in the main loop, and that's the part that I'm looking for, so I'll just copy this inside our main loop, setting the values for the variables item selected previous and item selected next. Once we have those variables set, we are drawing the strings from this menu items array, so this will be item previous. I will copy it into the first line. So menu items, item selected previous. Then we want to draw the string from the array menu items with the index of item selected. And finally the last item is from the array menu items with the index item selected next. So that's the last item, and let's restart the simulation. And now we are drawing dynamic labels from this array called menu items. And we can test if everything works by changing this item selected to, for example, number 2 and restart the simulation. And now the middle item should be dashboard, so it seems like it's working. But we don't want to switch between menu items by changing the value in the code. We want to use buttons, same as in this sketch. So I will copy the definition of the buttons into our sketch, but since we only want to switch between menu items and not to select anything, I will delete the middle one, and we want to use some empty pins, for example PB3 and PB4. So let's say that the button up will be PB4 and the button down will be PB3. And if I jump back to the Arduino Uno version, inside the setup function we are setting those buttons to be input pull-up, which is something that I will copy as well and paste into our code. And this means that if nothing is being connected to those pins are reporting high state, so we should use those buttons and connect them to the ground. So I'll stop the simulation and add a push button. Let's connect the push button to pin number PB4, that will be the button up, and let's add one more button, and this will be for down, and that should be connected to pin number PB3. And both of those buttons should be connected to ground, so let's connect this to ground and also this to ground, and maybe change the wire's color so it's clear what's going on. So if the button is not being pressed, this wire is not connected to anything, so the pin will be reporting high state, and if I press the button, I connect this wire to the ground and it should be reporting low state. In the Arduino Uno version, I have this extra code making sure that if I press the button and hold the button, it will just only act once. I probably don't need it for our ATtiny85 version, so I just copy the digital read function and paste it into the loop on the very end. And I will say that if the button up pin is low, meaning that the button is pressed, I want to change the value of item selected to be item selected -1. Now I can do the same thing as I've done in here, saying that if the item selected is smaller than 0, it will be the number items -1, but I think that I can also simplify it by using the modulo function, which will return the remainder of the division. And just because this might go below 0, I will just add the number of items to this equation. I will use something very similar for the button down, except of course the button pin will be button down pin. And instead of subtracting 1, I will add 1, and I don't need to add the number of items because now the number will be always positive. And I think that's all that we need, so let's restart the simulation. And as I press those buttons, I'm jumping between different menu items, but something is wrong. You can see there is some kind of glitch where the previous label is being displayed. And it all makes sense because what we are doing is we are drawing the label, and when we draw the new label, it might be a smaller one, but we are not changing this area, so based on the weight of the label, we might still see some leftovers from the previous string. And there are multiple ways how to solve this. We can draw the background image inside the loop as well, but now everything is very slow, actually so slow that you can see the blinking. We draw the image and then we draw the labels, so it's not very useful. We can also draw a rectangle before drawing the string, but we still might see a little bit of blinking, so probably the best way is just to fill the right side of the area after drawing the string. So this will be drawn, and here I will draw something like this to clear the leftovers from the previous string. For that we can use a function called fillLength, which is not very well documented, but it takes a byte, 8 pixels, and then you specify how many columns you want to fill with that byte with those 8 pixels. So let's just call OLED fillLength, and let's specify some byte value, and I will say capital B, so I can set those individual pixels, those individual bits, and I need 8 of those, so 1, 2, 3, 4, 5, 6, 7, 8, and I'm setting this checkerboard pattern to see what's going on, and let's for example fill 20 pixels, so 20 columns. Once I restart the simulation, you can see that after I've drawn the string, the label, I have filled 20 columns with this pattern. And of course, I'll probably need to fill more than that, for example, like 40 pixels. And not only I need to fill it on this page, but also on the next page. And for that, I need to know on which position I'm currently in. And there are thankfully some functions for that called getCursorX and getCursorY. And then there is the last function called setCursor. So as a first step, I will store the x and y value into variable stored cursor x and stored cursor y. And I will create a new variable that I will call clear width, and it will store how many pixels do I need to actually fill in order to fill the entire line. And I don't want to go all the way to the pixel 128 because there is this outline of the selected item and also the scroll bar. So let's for example say 120 pixels should be enough, and I will calculate it by saying that the clear width is 120 pixels minus stored cursor x, which means that now I can use this clear width as the width for the fillLength function. And if I restart the simulation, it should always fill the pattern to the same ending point, no matter which item is actually selected. So I just need to fill the next line as well, and I can do this by setting the cursor to be the x position, so stored cursor x, and I need to increase the y by 1, so stored cursor y plus 1, and then I will call the same function the fillLength for the next page. So if I restart the simulation now, hopefully everything after the label will be filled with that pattern, no matter which item I choose. I'm doing this for the middle item, but of course I need to do it for the top item as well as the bottom item, and maybe instead of just copying this code 3 more times, I can turn this into a simple function, which actually doesn't need to return anything, so I'll start with void, and let's call this function fill the rest of line. I actually don't need any parameters because everything is hard-coded. I will just move the code in there, and then call this function after drawing the first item, the second item, as well as the last item, the third item. And since I can confirm that everything works, I can now change this pattern to be full black, which I can do by changing all of those bits to 0, or I can simply say value 0 instead for both lines. And one last restart, and we have a menu with those labels displayed properly. Actually, the last item is covering the background a little bit more than I want to, so I might as well change the maximum fill value to only 110 instead, and that should fix it. So at this point, the remaining steps are adding the icons, adding a functional scroll bar, and running it on the real ATtiny85 chip. So let's start with those icons. It might be tempting to use the icons from the Arduino Uno menu, but those images were created using the horizontal drawing mode and we need those in the vertical mode. So we again need to use the image to CPP website to generate those arrays for us in the correct format, being the vertical format. Click the generate code and copy the output, and inside our sketch let's add one more header file and let's call those icons.h. I will paste it in here, and you can see that we have this helper array, and we are using something similar in the Arduino Uno menu. So I guess what I will do is I will just copy this array from the Arduino Uno project into our project. Make sure that the names are the same. I'm using the EPD prefix, so I'll just add this one as well. And then I can delete this array. So now I can use this bitmap icons array to draw the icons in the main code. But before I do that, I of course need to include this icons.h file, like so. For drawing the icons, I will use the OLED bitmap function, the same one that we are using for drawing the background image. But of course we want to specify the correct icon name, and we can look into the other sketch, because we will use the same array. In the first case it will be the bitmap icons with the index of item selected previous. If I measure it inside of photopea, the distance from the left side should be 4 pixels. It should be displayed on the first page, which is index of 0. The right side of the icon is 4 pixels plus 16, and the bottom page is page number 2. I will copy the OLED bitmap also for the middle item. In this case, we'll draw the bitmap icons of the index item selected. And we just need to change the pages. So the first page will be page number 3, and the bottom page will be page number 5. And one last copy for the last item. In this case, the icon that we will be drawing is bitmap icons of the index item selected next. And the first page is page number 6, and the last page is page number 8. Let's restart the simulation and see how it looks like. And we have the icons, and it looks like a proper menu. Which means that we are only missing a functional scroll bar. And I will cheat a little bit because I have 8 different items in the menu, and there are 8 different pages on the display, which means that I will always draw the scroll bar handle inside this page, and that will simplify things a lot. Let's define the images for the scroll bar handle and the background, and since those images are very simple, we can probably define those inside our code using zeros and ones. I will just borrow one of the icons from the icons.h file, copy it in here, and change the name of the image to scroll bar empty. And I want this to be 3 pixels wide and 8 pixels tall, so I need 3 bytes. The first column will be empty, so all zeros. The second one, the middle column, will be a checkerboard pattern, so 0, 1, 0, 1, 0, 1, 0, 1. And the last one will also be empty, so all 8 zeros. Let's create one more image, and we will call this scroll bar filled. And in this case, most of the pixels will be filled, except for the first and last in the first and last column. Like so. Let's draw the scroll bar after we draw the menu items. And just because we want to draw the scroll bar on 8 pages, I will add a simple loop for each individual page, and I will create a simple if statement saying that if I equals the item selected value, we want to draw the scroll bar handle, which is image scroll bar filled. Otherwise, we will draw the scroll bar background, which is image scroll bar empty. And I will just borrow one of those OLED bitmap functions, use a proper image name, which is scroll bar filled in this case. We can measure the position inside photopea, so the X position will be 125 pixels. The right side will be 125 plus the width, so it's plus 3 pixels. And we want to start on page I and end on page I plus 1. And then I will copy it one more time, and this time we will draw the scroll bar empty. So let's restart the simulation. And indeed we can see the scroll bar moving as we list through the menu. Before we run it on the real ATtiny85 chip, let's do one more optimization. We are only drawing the background image inside the setup function only once, and then inside the loop we are drawing those icons, those labels and the scroll bar. But we are actually drawing it all the time, even when nothing is being changed. So one very simple optimization will be only to change the content of the screen when the selected item is different from the last time. And for that I will create a new variable, and I will call this item selected displayed. And inside loop function I will say that if the item selected displayed doesn't equal the item selected value, only in this case we will redraw the content of the screen. And of course after we draw everything, I will set the item selected displayed to equal the item selected value. And just to force a redraw in the very beginning, let's just set the item selected displayed to some value which doesn't exist in the menu, for example number 10. So if I restart the simulation, there should be no visual change, but now the ATtiny85 chip has much better time processing stuff inside the main loop, because most of the time we are not updating the content of the screen, we are only reading the state of the buttons, so immediately as I press the button, I will jump to the next item. So I think that we can call this done and run it on the real ATtiny85 chip. For that we need to start the Arduino IDE and start pasting the code in here, but we have so many header files that it probably makes more sense to just click this icon and select the download project as a zip file. And once you do that and extract it, you can open it in Arduino IDE and you will also get all the header files inside. There is also this diagram.json file that we don't need. I can just click those three dots and delete this file from the project. Now before uploading, we need to make sure that we have all the libraries installed, which is the TinyWire-M library used for the I2C communication and Tiny4K OLED used for drawing stuff on the display. If you don't have it installed, just search for the library name and click the install button. To upload the sketch on the ATtiny85 chip, I will be using Arduino Uno as a programmer. And I've already described this in my previous video. You should definitely watch it if you haven't watched it already. I will put the link down in the description. But in short, you'll first connect the Arduino Uno, and then inside File you will select Examples, Arduino ISP, and upload this sketch to the Arduino Uno. After this is done, you want to connect the capacitor between the reset pin and the ground pin to make sure that the Arduino Uno will not restart anymore. And then connect the ATtiny85 chip to the Arduino Uno pins as listed on the screen right now. The ATtiny85 chip has 8 pins, but we only need to connect 6 of them. And as you can see, I'm using this prototyping shield which nicely snaps on the Arduino Uno. And once we have everything connected, we will jump back to the Arduino IDE, go to File Preferences, and in the additional boards URLs, paste this line. I will put the link again down in the description. Click the OK button, open the boards manager and type in ATtiny85 and install this package. And once the package is installed, go to Tools, Board, ATtiny and select ATtiny85. Then open the Tools menu again, make sure that the processor is set to ATtiny85 and the clock is set to internal 16 MHz. The programmer should be Arduino as ISP, and then click the Burn bootloader. And it might be confusing because it will not burn any bootloader, but it will set the correct fuses. And you can see I have the error message because I haven't specified the port for the Arduino Uno, which in my case is connected to the COM14. So let's do this again, Tools, Burn bootloader, and now it was successfully burned. So I can finally upload the sketch by going to Sketch, Upload using Programmer. And it was programmed, and as you can see it's taking 81% of the flash memory and 45% of the dynamic memory. So we still have a little bit of breathing space. Once the sketch is uploaded, I've recreated the same wiring as was in the walkway sketch on this small breadboard. And the nice thing about walkway is you can actually also add the breadboard, actually a few different types. So what I will do is I'll just recreate the connection in here so it's obvious what's going on. And while I'm doing this, I will also delete the old display and use a newer one which works exactly the same, but it only has 4 pins. There are only minor differences between my real project, and that is my display is slightly bigger and my buttons are slightly smaller, but the wiring is pretty much the same. And in the end it looks something like this. So one button is connected to the pin PB3 and the second button is connected to the pin PB4. Then I have the ground which is connected to the power supply ground but also goes to the second pin of first button and to the second pin of the second button. And I'm also using this wire to connect the ground to the display itself. The 5V power supply goes using this line to the ATtiny85 chip but also to the VCC pin on the display. And then the SCL, the clock, is connected to the pin PB2. And SDA, the data, is connected to pin PB0. And that's pretty much all the wiring. As for the power supply, I'm using 5V and ground from the Arduino Uno board. But you can also get this kind of cable where there is a USB connector on one end and crocodile clips on the other end. And it costs a fraction of the dollar. But when we connect the power supply, we see something on the display but it looks very wrong. We can press the buttons and we can change the menu items, but there are some vertical stripes and everything is faded out. So I guess we are not initializing the display properly. And after a little bit of googling, I have found this example called the double buffered millis, which is a comment in the setup function saying the default state of the SSD 1306 doesn't turn the internal charge pump, and so it's calling the enable charge pump function, and I will copy this into our code as well. Paste it after the OLED begin function and then go through the usual upload process by going to Sketch, Upload using Programmer. And that seems to fix it. So we finally have our menu displayed on the OLED display driven by the ATtiny85 chip. And of course I can press the button to go to the next item and the R button to go to the previous item. And if I press it and hold it, it will scroll through all the menu items, which is probably not something that you want for your final project, but it nicely shows how fast the menu is. And that's pretty much all for today. As usual, you will find all the files on the GitHub. The link is in the description. If you have any questions or comments, please put those down below the video. Thank you very much for watching, and I hope to see you soon. Thanks and bye.